The next question we're going to answer is to find the open time intervals where the function is speeding up and slowing down. Now, I specified open intervals. That just says don't include the endpoints. Okay. Now, a lot of times people say, oh, we just need to look at the acceleration because we're talking about essentially how the speed is changing. But yes, we're talking about how the speed is changing, not how the velocity is changing. Speeding up means that the speed is increasing. Acceleration isn't the change in speed, it's the change in velocity. And velocity is a signed quantity. So I need to break this up into two cases. Case 1, the velocity is positive, and case 2, the velocity is negative. And let's see what it means to be speeding up in those two cases. I've also put up here on the board this number line where we had recorded the sign of the velocity so that we can see that for this particular problem, we do have a time where the velocity is negative and another time interval where the velocity is positive. Okay, now if velocity is positive, then speed is actually the same as velocity. So in that case, speeding up means that the speed is increasing. Speed is the velocity in this case, so that would mean that the velocity is increasing. So we would want the velocity to be increasing, which means we would want the acceleration to be positive, because the acceleration is the rate of change of velocity. Okay, but case 2, if velocity is negative, then speed is actually the opposite of velocity. So if I want the speed to be increasing, but speed is the opposite of velocity, kind of makes some sense that I maybe want the velocity to be decreasing. And let's think about it. If velocity is a negative number, let's just say velocity was, just for example, -3. And if I were to go to velocity -1, that would be increasing. -1 is bigger than -3. But when I take the absolute value, which would give me the speed, this has a smaller absolute value. If I decrease the velocity and were to go to something like velocity equals -5, -5 is less than -3. The velocity would have decreased, but the absolute value, the speed, is bigger. Okay? So it is the case that if velocity is negative, so that it's the velocity of speed, if I want the speed to increase, that means I want the velocity to decrease, which means I want the acceleration, which is the derivative of velocity, to be negative. Okay? So, if velocity is positive, we'll be speeding up if the acceleration is also positive. But if the velocity is negative, we're speeding up if the velocity becomes more negative, which means it's decreasing, which means the acceleration must be negative. So the rule here, I can sort of summarize it, even though I broke it up into two cases. We will be speeding up if velocity and acceleration have the same sign. And that means that conversely, we will be slowing down if the velocity and acceleration have opposite signs. Okay, so I know the sign of velocity already. I'm going to create a number line for the acceleration as well and record its sign. Now for this particular example, it's pretty straightforward because the acceleration is 2, that's positive. So the acceleration is always positive. Okay. Now what I'm going to do is I'm just going to create a third number line here where I compare things. So I've marked off my endpoints, 0 and 4. Okay. I'm going to also mark off 2 because that's the place where velocity changes. If there were a place where acceleration changed sign, I would mark that off as well. I'm going to mark off all the points where either one of them changes sign. And then just to make it easier to compare, I'm going to just sort of fill this in. Velocity was positive on this entire time interval and negative on this entire time interval. And acceleration was positive over the entire interval from 0 to 4. Now I can see from 0 to 2, velocity is negative, but acceleration is positive. I've got opposite signs. And from 2 to 4, velocity is positive, but acceleration is also positive. I've got the same signs. So where I have opposite signs, that's where we were slowing down. So that's the interval from 0 to 2. Okay. Now, I don't want to include 2 because at 2, the velocity was 0. That doesn't really have a sign, so I don't have opposite signs there. I chose not to include 0 just because the directions said to name an open interval. If I hadn't said that, I could include 0 because at 0, the velocity is still negative and the acceleration is still positive. But I thought it would be easier if we just kept it consistent, since we don't want to include endpoints where velocity or acceleration is either 0 or undefined. I just decided not to include any endpoints. Okay, speeding up, that would be where we have the same signs, so that would be from 2 to 4. Okay. I want to just tie this in for a moment with what we did when we were graphing a derivative. Okay. So if we have, I'm going to say v of t here and t here. So v of t, we'd be graphing the derivative of the position function. Now when we were graphing derivatives, we said that we were concerned about where things were positive and negative, where we were going, position would be going up and down, but also how steep it was. So we said there were 2 steep zones, and that would be where the absolute value of the slope, or the absolute value of the derivative, was big. Steep, I can now interpret as fast. When the graph of position is steep, the slope of the tangent line is going to have a big absolute value. But that means the absolute value of the velocity, or the speed, is big. Not so steep. That now corresponds to slow. Okay. So notice, if this is where I'm graphing the velocity, which is the position, if velocity is positive, that would put me above the time axis. If it's also increasing, we're moving from not so steep to steep. So if velocity is positive and increasing, meaning that the acceleration is also positive, we're getting faster. We're speeding up. But if the velocity is negative, so that would put me below the time axis, in order to be speeding up, in order to be moving towards faster, we would have to be moving down. So velocity would have to decrease, meaning that its derivative, the acceleration, was negative. Okay. So that confirms what we figured out, that speeding up is when velocity and acceleration both have the same sign. They're either both positive, so that we're above the time axis and moving up, or both negative, so that we're below the time axis and moving down. And we're slowing down when they have opposite signs.